Hello, my name is PJ Solomon. In this project, we evolved quadrupedal phenotypes in varied terrain for the Evolutionary Robotics class at UVM. As an introduction, our hypothesis was to determine whether the basic quadruped model could be improved by allowing the evolutionary algorithm to influence the phenotype or physical qualities of the robot, and whether doing so can improve the performance in varied terrain. For this project, we altered the lengths of the upper and lower limbs of the quadruped robot. As for the process, the first step was to create this varied terrain. We did so by generating a number of collision-enabled boxes around the environment in which the robot exists. Next, we altered the code for the robot so that it could take in a variable leg length and evolve that over time. And so we can actually see a robot that has not had its limbs evolved over time. It is able to get some fitness and move forward to a degree, however, does not do great. All of these robots' fitness is determined by how far into the screen they can move. This one, it does end up colliding with an object and fail. This next robot has its legs evolve, and you can see it actually has those legs about the exact length needed to fit in between the obstacles. It also is able to use those obstacles to sort of push itself forward. So a great example of evolution adapting to the terrain. This next robot kind of ignores the terrain entirely and adapts bipedal motion as a means of overcoming the obstacles in its way. Um, Longer legs obviously means it's easier to step over obstacles, and if your legs are long enough, you can kind of ignore them entirely. That said, if your legs are entirely too long, you might just fall over, as was the case with some robots, especially considering that the fitness function was exclusively their distance into the screen. As you can see, the robots in green, which are the robots that had their leg lengths evolved most aggressively, did very well. They had the highest max by a quite considerable margin, and their average was higher as well. You can also see the fitness function. The jumps are mostly due to big changes in the phenotypes, whereas the blue normal robot or the previous robot didn't do quite as well. As far as conclusions go, we found that longer legs allow for greater movement, especially in this rugged terrain. Larger robots require less coordination, and evolving the body and controller worked well. You can see that there's similarities to other organisms like spiders and crabs. Thank you.